Hey geometers, welcome to a video lesson with Mr. Forster. Today we'll be going over Unit 6, Lesson 5, or 6.5 in the textbook, which is the triangle inequality theorem. Let's go ahead and get started. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is going to be greater than the length of the third side. So, a couple of examples that we can look at here. If xy is our first side, and we add that to yz as our second side, then that should be greater than the length of xz. And hopefully you saw this during the Desmos activity. Just a reminder, if you have not done the Desmos activity that is posted in Google Classroom yet, please make sure to go back and do that first. Here, I can also have yz being the first side that I look at, and xz being the second side that I look at. If I add these two side lengths together, it should be greater than this side here. And finally, if I have xy and xz, those two side lengths should be greater together than yz. All right, our first question that we have to play with this topic is, can a triangle have sides with the given lengths of 7 feet, 3 feet, and 8 feet? And we can justify this by showing some calculations. So take a moment, try and figure it out on your own, and then come back and take a look and see how you did. All right, the first one I'm going to test is the first two. If I take 7 and 3, if I add those together, that would be 10 feet, which is greater than 8, so that part checks out. If I take 7 and 8 together, that definitely is greater than 3, so yes, that part checks out. And 3 and 8 together is greater than 7, so all three of these inequalities are satisfied, which means yes, these three lengths are possible to have a triangle out of. These three sides can, in fact, make a triangle. Part B, this time we have 10 centimeters, 6 centimeters, and 3 centimeters. So again, take a moment, pause, see if you can figure it out, and then check back. All right, hopefully you got this far. So again, I did 10 and 3 is definitely greater than 6. However, if we look at these second two, 6 and 3 is not greater than 10. It would be 9, which is less than 10. So in this case, no. We are not able to satisfy all three of the inequalities, so these three sides cannot make a triangle. Another question we may ask ourselves is, well, what values could that third side be if I know two sides of the triangle? And so we have this triangle here, this proposed triangle that has one length of 3 centimeters and another length of 5 centimeters. We want to find what are all the possible lengths, plural, of the third side. And what would that look as the smallest version of itself? What would that look as kind of the biggest side length for that third side? So for the smallest possible length, one thing we could do is we can take the two values that were given, 5 and 3, and we can subtract them. And we're going to take 5 and subtract 3, and that means that our smallest side has to be greater than 2. It can't be equal to 2, it must be greater than 2, because when I add 2 and 3 together, it has to be greater than that 5. And for the largest possible length, similarly to what we did for the smallest possible length, we are going to, instead of subtracting, we will add these two side lengths together. So if I add them together, then I would get 5 and 3 is 8. So that means the largest side should be less than 8. Because if it was completely all the way to 8, then this would flatten out and I wouldn't have a triangle anymore. And then same thing over here, if it was all the way down to 2, then these two sides would kind of collapse in on that length of 5, and I would no longer have a triangle. For part 5, take a moment and see if you can figure that one out on your own, and then check back in a few seconds and I will reveal the answer. All right, for our smallest possible side, we take the side lengths of 8 centimeters and 10 centimeters, and again use subtraction to find the smallest possible length. So we know that it has to be greater than 2 centimeters. And for the largest possible side, we can take the two and add them together, so it has to be less than 18 centimeters. And we have a convenient way of writing this all in one succinct format, which is we have this inequality where we would say 2, which is our smaller value, is less than t, which is standing for our third side, which is less than 18. So t falls in between 2 and 18 when we write it this way. We could also say t is greater than 2 and t is less than 18, but this is just a little bit faster way to write this. Instead of having to write two inequalities, we can write it as one compound inequality. Continuing on, we have the triangle longer side theorem. Yes, that is an actual theorem from your textbook. And it says that if one side of a triangle is longer than another side, then we have this situation where the angle across from or opposite the longer side will be larger than the angle opposite the shorter side. So for a visual representation on our triangle XYZ here, if I have angle y being across from xz, xz is clearly the longest side in this case, then angle y will be the largest angle, or if we know that angle y is largest angle, then we're going to know that xz is the longest side. And similarly, if we know where our smallest angle is, or our smallest side is, those are going to be across from each other as well. So if xz, which is our green side here, is greater than xy, then the measure across from it, which is measure of angle y, is going to be greater than the measure across xz, which is the measure of angle z. So let's take a look at this in action again on number 7. So it says to list all of the angles of the following figure in order from smallest to largest. So take a moment and see if you can list those in the correct order, and then again check here for the answer. Right, since we're going from smallest to largest, we'll start with the smallest first. Angle A is across from BC. BC is the shortest length of 18 feet. And then next, we have kind of the middle-sized length is A to B, which means that angle C is going to be the middle-sized angle. And finally, AC is the largest side of this triangle, so angle B is going to be the largest angle. Next, very similarly, we have the triangle larger angle theorem. I feel like I've been harping on the people that write textbooks all week this week, and I feel like in geometry things are named exactly what they are, but this one just seems to sound weird coming out of my mouth. Anyway, it says that if one angle of a triangle is larger than another angle, then the side opposite or across from the larger angle is longer than the side opposite or across from the smaller angle. So again, our visual, if I have the longest side over here, the largest angle will be across from each other. So if I know that A is the largest angle, BC will be the longest side. And if I know angle B is the smallest angle, then side AC will be the shortest side. They are tied together in being across from each other. So here, if the measure of angle A, which is this one, is greater than the measure of angle B, then across from it, BC will be greater than across from angle B, which is AC. So again, let's look at an example where we have this triangle TUV, and we're going to list the sides of the following triangle in order from shortest to longest. So take a moment and play with this one on your own and check back in a few moments for the solution. Okay, well, it would be convenient if we had all three of the angles. However, we're missing one of them, so we can use the fact that all three angles of a triangle add up to 180 to get our missing angle. So I take 180, subtract the 58, and subtract the 62 to get that angle T has a value of 60 degrees. From here now I know that angle U is the smallest angle, which means that TV is going to be the shortest side, since we're going from shortest to longest. And then I would say, okay, angle T is the kind of most medium-sized angle in this triangle. So UV is the one that's going to be across from that. And then finally, since V is our largest angle, we are going to have TU, or UT, that is the largest side, or longest side. And that is the end of our video lesson today. Your assignment, if I remember correctly, is through the textbook. Check Google Classroom. Everything should be in there, including this video. So if you've already found this, then I'm sure you're already able to start working on the assignment. And have a fantastic day. I apologize again for being out, but hopefully things go smoothly on your end. I will be chasing my toddler around all day here. So thanks for making it all the way to the end of the video, and have a wonderful day.